questions would be in a final exam? And should we worry about time management?
Time is the main issue, really. We'll get a chance to look at more exam papers when we're finished, but the semester one exam is okay, you know, it's not so bad. It's the semester two, you know, because it covers both semesters, that's the issue.
Semester 1's bias UK.
Both are, yeah. Yeah, perhaps so.
And not just only one.
Which is the first one that's not correct?
It's not the one. 3C and 3D.
3C and 3D. Maybe. Question, yeah. I can check those in the tutorial, but you don't need to do number 3, but I'll do them in the tutorial anyways. Yeah. Yeah, so, do you have the original sine graph?
Which one?
The very first one. Yeah. So originally, sine goes up to 1.
Yeah, I know.
I know that's okay. Yeah. So the effect of the 2 here is to make it twice as big.
Yeah.
So instead of going to 1, it goes to 2. And likewise, instead of going to -1, it goes to -2.
Yeah, but then why does it change?
That last one is the D, which is the +1. The effect of the +1 is to move the graph up 1 unit. So if it stopped at 2, it now stops at 3. And if it stops at -2, it now stops at -1. Yeah.
Okay.
Yeah?
Yeah.
So these 4 are supposed to match up with the
Yeah.
4 transformations
Yeah.
then. Yep. You want me to check the C, is it?
This is 32. It's this. So you said in this graph, the peak is
2.
2 and -2. So it should be A should be 2, isn't it? Yeah, I think that's
Yeah, A should be 2. What do I say?
it's 1.
For D.
Yeah.
You're right. That's definitely a mistake.
And C. So if you see the C,
Yeah.
it should be 1. The A should be 1 because the total range is 2. It's from 0 to -2, and the total range is 2. I think if you divide it by 2, the A should be 1.
Yeah. Okay. So that's definitely a mistake. Yeah. Yeah. Thanks. I can try and fix that. Question? Yeah. Well, I just, you know, when you're typing so much, eventually you'll mistype.
How should I find the correct answer?
For which one?
The C.
Yeah. Well, the A is definitely 1.
Yeah.
The D is
0.
-1. Okay. You'll have to figure out the B and C carefully, because you should change that. If I can take your pen there, you should change that into B x plus C. So the C looks like it's been moved pi over 8, and the B is how big is the period here?
Double the fraction. I think B is 2.
B is 2. So that means this B is 2 and this C is 2 times pi over 8. So that's pi over 4. Yeah. I think.
Pi over 16?
Yeah, pi over 4. Do you know what?
Pi over.
No, do you know what? You think C and D is wrong, yeah? I'll do C and D in the tutorial as an example. But I think you're right. There's a mistake. No, I think you're right. Question, yeah. Yeah? Yeah, the A is 2, agreed? So that has the effect of making it twice as big. So instead of stopping at 1, it stops at 2. It stretches up. It's like, let's draw it. Oh, you didn't write that rule down. Oh no, there you did, sorry. Yeah, 8 times larger. So the 2 makes it twice as big. So instead of stopping at 1, it stops at 2. Yeah?
So I'm supposed to add 2 minus 1.
Multiply them by 2.
Okay.
Yeah. Alright guys, we'll continue now.
Don't think not to make it primitive.
Oh, don't be such a drama queen, please. Alright, we'll continue now. If you can look up, please, look up. So, we're on to the next section now. So, we're not doing anything particularly new in this lesson, just to get us started. We're going to go back to something we did in the first chapter. You remember we looked at problems where we had one linear and one quadratic. Do you remember that? So for example, we could have a quadratic and we could have a linear. And how many solutions does this have? 2. But now we're looking at a situation today where we could have only one solution. And I think you should remember, I called this a tangent. And I also told you what this line is called. Does anyone remember? Yeah. Secant line. So what we will look at here is a couple of examples, none too difficult. Our first example is I give you a linear and I give you a quadratic. Well, no, let's, yeah, okay, I'll just use that one. And my question is this linear a tangent or a secant? How could I figure that out? Fine. Well, no, we didn't do that yet, so something else. Not quite sub it in. Well, I mean, what are you trying to figure out? The solutions, yeah. Yeah. Basically, if I can find the solutions, I can answer the question. Because if I get 2 answers, then what situation must I have? I must have a secant. If I get 1 answer, a tangent. So let's see what happens. So I have 9x plus 9 equals minus 4x squared plus 5x plus 9. So I get 4x squared plus 4x, and the 9's cancel. 9 and the 9 cancel. Yeah? So I don't really need that 0 there. And I'll divide by 4. Okay, what's the easiest way to solve this quadratic? What method? Factorize. X plus 1. So, I don't need to solve it. I don't. I just need to know how many answers there are. How many answers do I have here? 2. So, it's a secant, not a tangent. Now, let me draw that to show that. I'll draw it here for you. Y equals 9x plus 9. Y equals minus 4x squared plus 5x plus 9. Now, I'll zoom out. Oh no. Now you see, it's interesting. It looks like it's a tangent, but if you actually get the scale correct, you can see quite clearly it's not. It's almost a tangent, but it's actually not a tangent, it's a secant. Okay, so that's our first example, if you can write that down, and we'll have a look at another one now. Can I scroll down? Mariam? Not yet? Okay. You have this? Yeah? I think we're all waiting for Mariam, yeah? Which part are you at? Okay. Got it? Okay. Right, so next question now. I'm giving you, I'll let you try this before I do it, because it's a bit tricky. I want to see if anyone can figure it out. I'll give you a quadratic. We'll say y equals 9x squared minus 3x plus 4. You know what, let me draw it for you quickly here. Y equals 9x squared minus 3x plus 4. There it is there. Okay, so roughly speaking, it looks something like this. And I want you to get the equation of this line, the equation of the tangent line when x is 0. So this is x is 0 here, obviously, because it's where it crosses the y-axis. So yeah, you know, very good, you know that this point here is 0, 4, this point here. Good, good. So I'll give you a minute. I want the equation of this line. And my hint is you need to think about the last question and what is special about a tangent line. Yeah, I want you to find the equation of this line. And I'm telling you now, for those students who know about the derivative, you can't use the derivative if you know about it. So just to help you, your first job is to figure out a way to get the m. Because the c is actually easy, because you have the 0, 4. Yeah. So you actually know what the c is. What's the c for this line? 4. Okay, so your next job is to get the m. Which equation? Why or how could it be wrong?
Don't you need another point from the 9th point?
Normally, yes. But because you know that this is a tangent line, that gives you enough information to figure it out without the need of another point. Yeah, no derivatives. You can, and that will let you figure out the c, which is what I wrote here. So you need to do something else to get the m. Yeah. But you're right, the way I got the c was by making x 0 and y 4. Yeah. You can make c 4, yeah. So yes, but you can't use these again. You've used them already to get the c. It won't work to use it the second time to get the m. Now I see what you're saying. If you put that in there, can't you get the m? But the problem is because it's been used to get the c, it can't be used again to get the m. You won't get an answer.
What will happen if you equate?
I think you'll get something like 0 equals 0, so it's not useful.
Yeah, it is 0.
Oh, you've tried that already? No. Oh, we're getting desperate now. Yeah. But you can't factorize, there's no roots. Yeah.
And like it doesn't give you any roots because that's not a tangent to the curve. There should be one point, right?
You see, you're halfway there, but you've applied your idea the wrong way. But you're halfway there. Has anybody figured out what to do to get the M? Yes. But something before that.
Okay, then no.
No? No? Okay, I'll tell you. So look up, listen carefully. So the trick here is, because it's a tangent line, right, you know that if you were to solve this equation together with this equation, how many solutions should you have?
One.
You should have one. Well, let's solve it. So you have 9x squared minus 3x plus 4 should equal mx plus 4. This should have one solution. So that means 9x squared minus 3x minus mx should equal 0. This should have one solution. To make it a little bit clearer, I'll say plus 0 equals 0. Should have one solution. 9x squared plus minus 3 minus mx plus 0 equals 0. That should have one solution. Now, how do you know, or how can you check how many solutions a quadratic will have? The discriminant should equal what if it's supposed to have one solution? 0. So you can say b squared minus 4ac should equal 0. So that means 9 plus 6m plus m squared should equal 0. So you get m squared plus 6m plus 9 should equal 0. So you end up getting m equals minus 3, which you could have seen earlier. Which kind of makes sense, because if you look at the picture, the m should be negative. So Mubarak, you kind of had the idea, you were thinking that there should only be one solution, but you're forgetting that it's one solution for this system, not the quadratic by itself.
What time is this at?
Okay, this one's at 18 up. Say again? 18.
Is it a coincidence that they both have minus 3x? Or
Good question. Is it a coincidence that it's minus 3, is it?
yeah.
For what?
I mean the quadratic had a minus 3x and
Ah! Yeah, that is a coincidence actually. Yeah. Yeah. Say again?
Like because you know minus 3x minus this version of x, and they were looking for f which is the version of x, and we just say f is minus 3.
But that was only a coincidence at the time. Yeah. At least I think so. Yeah, coincidence. So it was only for that one. Okay. So there's nothing. This was really it for this lesson. There's nothing too difficult because they're all going to be like this. I don't really need you to do question 1 and 2. So all I want you to do only is just question 3, and we'll say, we'll just say 3A and B, okay? If you can do those 2, then that's enough for this lesson. And I'm sure you'll get those 2 done now. So if you can do those 2 questions now, please. No, don't bother with the sketch. Just get me the line. Yes. How many weeks did it take? Like 6 weeks, was it?
What? Three good took like 3 days. Oh,
Question.
Where did the 4 go?
look at
The
370.
4, where did it go? Ah, so you have a 4 here and a 4 here. So they cancel basically. So if you took that 4 over, you'd have 4 minus 4. So that's the 0 there, yeah.
And now for the next one.
Yeah. Is this the one you're doing?
Yeah, this
Yeah,
way.
yeah, yeah,
So,
yeah.
the points on the graph, is that where I get the key from?
Yep,
So
correct.
that's minus 4.
I don't have it open, but yeah.
But now that's minus 1, so they don't get it.
Exactly. So this will be minus 1 plus 4, which, yeah, 3. So you'd have 4x squared minus 7x minus m.
Plus 3.
Yeah, plus 3. I think you meant to write mx actually.
Did I?
Yeah,
Oh,
yeah,
yeah,
yeah, you
got
did,
it,
yeah,
got
yeah,
it.
yeah.
Okay.
Yes.
The m for